Hello, my name is Donnel and I'm going to present on the question 1, part A, which is the activity on node network diagram. Activity on node is a project management concept that refers to a precedence diagramming approach in which scheduled operations are represented by boxes. These various boxes are linked with arrows from the beginning to the end, represent logical progression of the planned activities dependencies. Okay, based on this table, we can see that the activity start with activity A. Then activity B and C can be done if activity A was done. Then the arrow from A to B and C. And next, activity D can be done when activity A and C was done. Next is activity C, which is depending on the activity B and D. Then activity E precedes activity F. The activity G is depend on activity C and F. So next, activity H can be done when activity D and G was done. Next is activity I can be done when activity F and G was done. And lastly, activity J can be done depending on activity H and I.
Assalamualaikum, my name is Rosmin and I will explain the question 1b. So before we go further to answer the question 1b, I will explain about the definition and the rule for the ES-EF network. So ES-EF network is begin at starting event and work forward. And the earliest start means the earliest time for an activity can start, and the earliest finish is the time for an activity can be finished. So the rule for the earliest start is if an activity only have single immediate predecessor, the earliest start is equal to the earliest finish. And the second rule is if the activity has multiple immediate predecessor, the ES is equal to the maximum of all the predecessor. So for the earliest finish, the rule is sum of its earliest start time and its activity time, which means the EF is equal to the ES plus activity time. For the LS-LF network, this network is begin with the last event and work backward. And the definition for the LS is the time for an activity can start, and the definition for the LF is the time for an activity has to be finished. So the rule for the LS is an activity is the difference of its latest finish time and its activity time. So it means the LS is equal to the LF minus the activity time. So for the LF, the rule has two rules, which is the first rule is if an activity is an immediate predecessor for a single activity, the LF is equal to the LS of the activity that immediately follows it. So the second rule is if an activity is an immediate predecessor to more than one activity, its LF is the minimum of all LS value of all activity that immediate follow it. This is the answer for the question 1b. So this is the example for this rule. So the ES of A is equal to the EF of the start, which means is 0. So the EF of A is equal to the ES of A plus duration time, or the activity time. So 0 plus 2 is 2. So this is the example for this rule, which means the early start of E is equal to 10 because we make a comparison between these two immediate predecessors, which one has the highest value. This is 10. So this is the overall ES-EF network. for the question 1B, and this is the as we can see here, this rule can be applied. This rule can be applied for this activity, which mean the LF is equal to the LS. So this LF is equal to the LF because the activity is an immediate predecessor for single activity, and this rule can be obtained. For example, this activity. So there are two. This activity is an immediate predecessor to more than one to this activity, and between these two, the value that taken is the minimum, which is 19. So this is the overall ESEF, LS, and ELF diagram network. So for the slack time is the length of time an activity can be delayed without delaying the entire project, which is the slack is equal to LS minus CS, or slack equal to LF minus EF. So this is the table for all the activity, which result the only activity we have a slack time, means that the activity can be delayed as 4 days delay can be delayed without delaying the entire project. So which means the others activity must be finished expected 28 days. So that's all for me. Thank you.
Hello everyone, good afternoon. My name is Milzam. Today I'm gonna present about critical path and duration. It starts with nothing, so it's all zeros, and this box indicate early start. This one indicate activity, which will be A, B, C, or A, B, C, D, E, F, G, H, and this is early finish, this is late start, this is late finish, and this is durations. So first project is it took 2 days, okay, and for D, C, and B, it all depends on A. That is why the arrow is come from A. Then for D, it depend on C and A. That is why the arrow it have the arrow from here. For E, you need it depend on B and D. For H, it depend on D and G. And for I, depend on G and F. And J, it depend on I and H. So by doing this path, this is called critical path, we can find the duration of the project, which is 28 days. Thank you.
Hi there, very good evening to you. I am Abraham, son of M.A. Peter Lutz. My matrix number is BK17160266, and today I am going to explain on my part of the assignment, which is the Gantt chart for the subject Management and Accounting for Engineers. Now, first of all, we will have to ensure that the AON diagram is correct. So when the AON diagram is correct, from there we are able to calculate the early start, early finish, late start, and late finish. So firstly, for the first Gantt chart, it is the depiction of early start and early finish, and as you can see, it is neatly planned and every single duration seems that is proportional from the start date till the end date. Okay, for the late start and late finish, each and every duration of days in between the activities are proportional except for activity B. Now, as how we have discussed in the assignment, I actually believe that based on consideration and a little bit of thinking, I believe that this particular activity may not be in the priority list in comparison to all the other activities. Thus, it falls later on after activity C and after activity D is completed. It falls in between the mid duration of activity D and also ends at the ending of activity D. Thank you.
For question 2, part A, this table shows the tabulated data of total errors of each activities, the cumulative and the percentage. This is the Pareto chart. Basically, the Pareto chart is a type of chart that contains both bars and a line graph, where individual values are presented in descending order by bars, and the cumulative total is represented by the line. From this chart, we can see that the machine variation has the highest error, which is 16, followed by power supply problems, followed by inadequate workers, and with three same value of errors, which is cutting tools, settings, proper maintenance of CNC machine tool, overheating of machine tools. And the least error is error in programming.